All right, I think we're going to go ahead and get started, even though we've got some people filtering through the food line. That's okay. We've got some introductory material and some announcements, so feel free to, still grab your lunch. A quick announcement to our online attendants. You'll be muted the entire time. If you'd like to ask questions, you can ask them through the typing pane. We've got somebody monitoring them. So if you have any IT needs or want to ask a question during the lecture, or we've got a Q&A session at the end, feel free to type it in. So with that, we're just going to go ahead and jump right into the presentation. We've got a lot of ground to cover. Lauren, can you click the background there? Yeah. There we go. Oh, hold on one second. This is an old version of the presentation. 1 second.
Oh, they're hidden.
There we go. That one. Start it.
Yeah. Hang on a second.
Okay, there we go. Back on track. So the biggest question is, why are we all here today, right? And I think it's because we're exploring different workflows from Revit or building integrated modeling in general to daylight analysis, right? So there's been a lot of advancements in terms of embedded analysis programs, in terms of the export process. So we're really interested in these new developments because they have the possibility to streamline workflow, to make the process faster and easier, and integrate more into the professional practice, right? So a lot of the stuff that we've been doing at the lab has been relegated to research, to academia. We've had a chance to work with some of the people in this room on more advanced daylight analysis, but we know that that process can be unwieldy at times because of the tools and their current state of development. So we've kind of categorized these workflows into 3 different buckets. There are various offshoots, but these are the main ones. The first one is a parallel workflow, which is kind of the typical way that we do our analysis currently in a lot of the industry does. And that's where there's a Revit model or a design model. And at the same time, a daylight model has been made in parallel by an energy analysis firm, research firm, or even an energy modeler within the firm itself, right? But generally, it's a separate model altogether. And as they go through this kind of iterative process, there has to be communication back and forth on any changes between the Revit model has to get communicated into the daylight model, and anything that you learn from the daylight model in terms of its geometry or shape, form, specs has to integrate its way back into the Revit model, right? So these kind of communication channels that are going through this parallel workflow, there's a lot of chance for error, QA, QC, it's increased coordination, it's increased meetings. This is basically how we generally work now because there's not as much integration as we'd like to see. So this is the kind of typical parallel workflow that we see most often today and that we use at the lab. The second one, which is the one that we're talking about today, is kind of this export workflow. And that's where now instead of there being kind of this parallel track of 2 separate models being developed in parallel, in tandem, that everything comes from the Revit model, right? So there's an export process one way to the daylight model, and then there's still communication that happens in terms of what you learned from the analysis, how that makes its way back up the chain to the Revit model. And now instead of developing that in series, the Revit model gets updated, it moves on to its next design iteration, and then you re-export to your daylight analysis engine or process. So this way, there's a lot less chance for error, or there's a lot more enhanced coordination possibilities because those changes are automatically in that model, right? So this has the potential to redefine workflow, streamline it, increase the process, and increase the quality. And this is the one that we're talking about today because there's a lot of different ways that you can do this. But it's worth mentioning that as these analytical capabilities of Revit kind of develop, so they're developing at a rapid pace, the embedded workflow is going to become more and more significant. And this is really, I would say, the ideal, right? This is the holy grail of daylight analysis, working with practice, being able to do analysis directly within Revit itself, right? That Analyze tab that's in Revit 2014, it's getting better It's not quite there yet, but someday it will have all of our kind of energy analysis, daylight analysis needs right directly within Revit. And the benefits, I think, are pretty apparent in terms of there's no communication back and forth between the model now being separate, the daylight model outside of the Revit model. They're embedded within, it's wrapped around, however you want to view the diagram, but they're one and the same. So as you update it, they automatically update each other. So the last slide on this kind of these diagrammatic differences, I just wanted to point out that we're going to be talking about the export workflow today for February 26th BSUG. But our next BSUG, we're going to have David Schreer from Autodesk's Building Performance Analysis Group come in and talk to us and demo some of the new 2014 Revit daylight analysis capabilities directly within Revit. And that's through the Revit Daylighting Analysis plugin. So we're really excited that we're able to get David to come out. Really appreciative that he could squeeze into a schedule. We're going to have it April 4th, which is a Friday in April. So the date's a little bit different. We're trying to accommodate a schedule, and we're integrating with the BoiRUG group, which is the Boise Revit Users Group. So we're going to have a joint meeting with a big name from Autodesk talking about the Revit integrated or embedded daylight analysis workflow. So that's coming up in the future. We'll be sending out announcements. I think that one will definitely be something to keep on everyone's radar. So to take a step back, we'll be talking about this workflow. So the agenda for today's meeting, we're going to do a little bit of an intro for 15 minutes. We've got 5 minutes left according to the clock. We've got a workflow diagram that we've created because there's multiple streams or multiple pathways throughout the export process, multiple file types, different programs you can import it into. There's a whole ecosystem around this second workflow that we're dedicating to today. So we've got this. This is a Prezi diagram, so we'll jump out of the PowerPoint. And then I will turn it over to Lauren, who's going to actually demo some of these different export pathways, right? So that'll be the real kind of meat and potatoes of the presentation. I'll give you guys a general overview to get your heads wrapped around the different options. And then Lauren will show you some of the nuts and bolts of the actual processes, their strengths and weaknesses and limitations. And then at the very end, we'll have time for QA. But if you have any questions throughout the presentation, feel free to, of course, jump in at any time. And we'll try to repeat them for our online participants. So with that, this is what the diagram looks like. We're going to go and jump into Prezi. Stand by 1 second. Here we go. Gotta love how Windows 7 collapses these down. There we go. I'm not sure how this is going to come through on the online participant side. Hopefully Prezi updates enough to where it doesn't look too jerky as we go through this, but try to bear with me if you're online if that is the case. So as you can see, this is a pretty complex diagram, right? So we didn't quite think that it was going to explode into this level of complexity. We didn't think that we'd have to make a 3D diagram that we'd have to zoom in and out of to communicate its processes, but it was either that or this was one of the original diagrams that we came up with. So I think this is going to be a lot clearer. And big thanks to Sierra Shaver. She was the one that kind of took our madness that we researched and turned it into something that was a little bit more visually appealing. So with that, so this is generally about how to get from Revit to daylighting analysis. There's some credits down here. It's a little bit hard to see with the projector. But essentially, we've distilled it down into a 5-step process. So step 1 is we export from Revit directly, and there's a whole host of things that need to be taken into account when you're doing that. Step 2 is we import it into a transfer program. So generally, this is going to be SketchUp or Ecotect is what we focused on today. There are other ones out there, but that's what we're most familiar with. There's a step 3, which is a model preparation and cleanup. So anytime we import it from these different file types, there's a certain amount of work that we have to do when we get that model into this other program. It's just not quite there yet to where it's a clean transfer. So there's always some amount of stuff that you have to do, which impacts what file type you're exporting from, what program you're importing into, and that's what we're going to cover. Step 4 is analysis prep in terms of once you kind of clean everything up, what do you need to do to kind of get it to that third-party daylight analysis software. And then step 5 is we're going to talk a little bit about radiance analysis, which of course is the program that we use for all of our high-powered daylight simulation. And so depending upon the workflows, you can also bypass this potential step here in terms of the transfer program. Depending upon the workflow, you can sometimes jump that and actually import it into the program that you're going to do analysis within, right? So there are some shortcuts to this process, but generally these 5 steps are what we found to be the most useful. So in terms of when we're coming, out of the main part of the diagram, we're talking about, let's say you want to do daylight analysis within Revit. You generally have 3 different options, right? The first one is the kind of 2 Autodesk programs that are within its internal ecosystem that have some type of daylight analysis capability, right? So one of those is which is currently, I believe, still in its beta version. It's free as it is in its beta version. It might be subscription-based in the future. We'll see how that pans out. But it's fast and easy. It's mainly for conceptual modeling, early stages. But it doesn't really do daylight analysis proper. It does insolation analysis, solar array analysis, a lot of kind of the sun studies, but it doesn't actually get into illumination or luminance analysis, right? So this really can't be used for, I think, the bulk of what we're talking about today in terms of daylight simulation. Green Building Studio gets a little bit closer. It's mainly for energy analysis, but it does have a calculation that estimates your potential to get the LEED credit, right? So it's really kind of a feasibility study to say, yes, you should explore this further, or you need to radically redesign the building to give yourself a fighting chance, right? But it doesn't still do illuminance grid analysis, perspective glare analysis, stuff like that. So we have to go outside of Revit to do this type of simulation, do this type of analysis, as it stands anyway. So one option is to do these Revit add-ins, which we talked a little bit about before, and that would be a plugin. I think add-in is the Revit language for plugin. And essentially there are certain pros and cons towards going with this. The biggest one being that you get to stay within Revit, right? So you get a little bit of that embedded workflow, which we think is really the best, most streamlined approach to going from BIM to SIM in this case. It's fast and easy generally, and the capabilities are getting more and more powerful. So like currently, the programs can't really do annual metrics, right? But I know that they're developing the RDA program, the Revit Daylight Analysis plugin. That's what David will be talking about next month. And Elam Tools is another one. There are other plugins out there, but these programs will do analysis grids. They will do perspectives, give you visualizations, and they're working to integrate annual metrics so they can be compatible with LEED version 4. Right, so these are going to be, I think, good options in terms of going down that add-in route. So the third route, which is the export route, this is the one that we're talking about today. There are certain pros and cons. The main pro being that once you get it into whatever third-party program you're doing, it's generally much more robust analysis. It's much more accurate. You have the flexibility of some of these more high-powered daylight analysis engines, right? So this gives you the most power and the most flexibility, but you've got to go through some pain to get there. And so the con is it requires additional time. Sometimes, depending upon where you go, you're going to radians in a lot of these workflows. It requires some text editing knowledge. Kevin's daylight simulation class is teaching that now. We offer workshops, but it definitely is kind of some high-powered analysis there at the end. And we'll show you some less scary pathways throughout this process as well. So when we go from that, so let's say we're dedicated towards that export process, we're going to talk about generally the different file types that you can export from and the implications on your process there, filtering down into SketchUp and OpenStudio, then also into Ecotect. But it's worth mentioning that there are these other programs out there, and we're not familiar with them because they're proprietary, but there is an ability to import from Revit into AGI32, popular software used by the industry for electric and daylighting analysis, and it accepts DWG and DXF files. You don't get the GBXML import into AGI32, but there is a pathway if you're interested. So we just wanted to mention that in passing. And same thing with IESVE, so that's another popular comprehensive suite, right? And this way you can actually import GBXML and DXF. You can't do DWGs, but you can do DXF. So these have their whole trees to themselves, but we wanted to focus on SketchUp and OpenStudio, our wheelhouse, and also Ecotect, something that traditionally we've used in the past. So to talk about the first file type, the option, there's the DWG option. So we're probably most familiar with this particular file type if you've been in CAD or Revit. And this is a good option for the most complete geometry, right? So you're bringing in essentially the same planes, the same forms, and the same surfaces as what you see in Revit or in AutoCAD. And what's nice about this too is it imports things in layers, which are easy to organize and apply materials to on the back end, right? So the way that these file types organize their information is going to have a big impact on how you apply materials in your third-party software down the road. And this is a good organized way to do it. Some of the cons is that the geometry isn't simplified, right? So what you see is what you get, and we don't always need all the detail that's in a Revit model for daylight simulation, right? So we don't want the furniture sometimes. We don't want all the trim details and stuff like that. So there's a little bit of model prep that goes on if you're going to use the DWG. You can't really just take the file, export it as the DWG, and bring it into the model. It's going to be a little bit too cumbersome that way. So there's a little bit more cleanup on this side. Also, one kind of weird quirk that hasn't been solved yet is that window panes come in as two separate planes, right? So they have thickness when you model them in Revit or in CAD 3D, and so they come in as two separate planes. So you have to make sure you delete one of them or that your window specifications aren't going up. So that's always something that you need to be aware of. And then we'll talk a little bit more about geometry implications down the road. So GBXML is probably the opposite, the other kind of most different export pathway in terms of its file type and its parameters. So what's nice about the GBXML process is it simplifies the model. And now there's automatic simplification within Revit. So beforehand, to get to GBXML in Revit, you had to go room by room, enclose the volume, do 100 times, there's 100 rooms to get it to GBXML. Now there's a lot of really great embedded analytical capabilities to where we'll interpolate those room volumes automatically, as long as everything's room bounding. So they've automated the process on Autodesk side to actually get it to the GBXML format, which is really nice. With that being said, material properties are exported to some extent in both the SketchUp and the Ecotect method. And what's nice is this also sets up the model for energy analysis. So if you're exporting it as the GBXML to get it to daylight analysis, you'll have the option to do energy analysis as well. And that's really what this file type mainly was built for, was exporting out to energy simulation. Some of the cons, though, is there's a couple of conversion issues that you have to do to get into Ecotect. So for instance, if you try to just import a GBXML, you'll get an error, something about IFC conversion, so you have to actually just save it as a different file type within Notepad++ or just Notepad. So it's just one extra step, but it's not too big of a deal. The organization is a little bit different. So with DWG, you get layers, right, from your CAD naming convention. So when you bring those in, you can group them easily. With the GBXML, it groups things as spaces or as rooms. So it's a little bit harder on the back end to separate walls from roofs from floors to apply certain materials with those, right? And with daylight simulation, we're worried mainly about the reflectances of the wall versus the ceiling versus the floor. So it's really useful to be able to separate those. So it takes a little bit more work with the GBXML process. And also, if you're in that simplification, it's really worried about interior volumes. So sometimes you'll get gap interpolations between those different zones or spaces or rooms. So that always has to be taken into account if you're trying to do perspective renderings, visualization analysis. Is that level of simplification? It might not be appropriate for that, but it might be fine for doing lead daylight analysis and stuff like that, right? The DXF is very similar to the DWG. Comes in as layers, you get the complete geometry. It's pretty much very similar to that process. Just glaze over that. Then you've got the FBX, which is similar. It's just another file type. There's tons of them out there. And this one is interesting because it takes two conversion processes to actually get it into Ecotect. So you have to either go through 3ds Max, which is a program that probably most of us are familiar with, or there are FBX converters to get into some of those programs. So, we've never used this one, but it's worth mentioning. It's one of the file types that are out there. What's even more important is which one of these file types go into which program. You also notice that we have one more layer of complexity to this diagram, and these are brief step-by-step procedures for exporting as DWG. These are the three main overview steps. We didn't really want to get into that too much with this presentation, or I'm sorry, with this presentation, because Lauren will be demoing. And also, we're developing a Word document that's a detailed step-by-step on how to do this for all these different pathways that we'll make available when we post the video as well. So we don't need to get into that now from me. You'll get a little bit more of it from Lauren here in the future. So the most important thing is which one of these file types will go into which one of these two different programs. So you can see that with the SketchUp Open Studio route, there's DWG, Access, GBXML. This actually goes straight into Open Studio. And DXF can be done in SketchUp. But you can't go from DXF to SketchUp, which is fine with me because we don't really ever want to use FBX if we don't have to. With Ecotect, generally what we use is GBXML, DXF, or FBX. So, there are some other pathways, but these are the kind of preferred workflow methods that we've used, that we've tested, and that we know work to some extent. So let's talk a little bit about the pros and cons. Why would we go into SketchUp or Open Studio versus Ecotect? Generally with SketchUp, it's easy to use, so it makes kind of model manipulation on the back end a lot less of a headache, especially compared to Ecotect. SketchUp is free, although to import some of these file types, you need the Pro version. So we were really trying to explore a free pathway, and we couldn't quite get there with SketchUp alone. However, with Open Studio, which is a free plugin to SketchUp, which does energy analysis, also some daylight analysis, there is a free pathway. Open Studio can import the GBXML, and so you do have a free pathway that way. But if you're going to do the DWG, the layer management, DXF, then you have to use SketchUp Pro to import those files. Generally, you can get a pretty long way with the trial version because you'll only need to open up, like 5-10 minutes at a time. The cons is the Pro is proprietary, so it costs money. And then also there's some downstream issues too in terms of how we prep that up for final analysis. In terms of Ecotect, the pros are it can export directly to the RAD process when we prep this for analysis, which is the yellow section of the diagram. There's one less step, so that makes it a little bit nicer, a little bit easier. But it's notoriously difficult to use, especially in a modeling interface. Nobody likes to model Ecotect. I've not met anyone yet that really likes its modeling interface or how you have to navigate around its three-dimensional space. But it's serviceable. One of the other cons is that, Ecotect is still kicking, but it's not being developed as much by Autodesk. Right? So Project Basari has been kind of stealing its territory internally in terms of what it can do. So, they're prepping Basari to be the next Ecotect, in my opinion. And so Ecotect at some point might die. So we're always really worried about how much it's being supported, right? And it's proprietary. So those are some of the cons of using Ecotect. But this has kind of been what we built a lot of our analysis workflow on at the lab, when we first started out. So diagram just keeps getting crazier and crazier, right? So when you're going from these different kind of transfer programs, remember there's model prep, right? So we get it from Revit. We have the geometry. We have however it came in. There's a certain amount of procedures and steps that we have to do to clean up that model before we can do analysis, right? And this is where it's worth mentioning that we really try to keep a workflow to where this was as minimal as possible. So if you apply material properties in Revit and come through these processes, they should come in to those transfer programs, right? So material reflectances should come in, so it kind of takes out that step, right? Currently, we have not been able to kind of do that in a smooth way, so that's why we had to spend so much time in this step to kind of reapply materials, make sure everything's good, do some geometry troubleshooting. All of that is still pretty significant in this workflow process. So eventually, it's going to become more and more streamlined where we don't have to do as much of that prep. But currently, there were some issues, with every export process that we tried to do, right? So this diagram, this presentation is still focusing on doing a lot of back-end reapplication of surface materials, stuff like that. Lauren will get a little bit more into that in terms of like the Revit properties versus import them in and what these references are. So we don't want to go into these steps, but I did kind of want to mention them to give you an idea of what they look like. So if we go into model prep, Ecotect, we're kind of checking for components that didn't come through, material properties, stuff like that. We're deleting the double pane, making sure that that's an explicit step. And also, step 4 is about that object application. right? So if you're doing the DXF method coming into this is about selecting layers by zone, which is, how they came in with CAD, and then applying your new materials down, right? So this starts to talk about all of that model prep that you need to do as well. Kind of a brief introduction. So almost to the bottom of the diagram, so this is about the kind of different analysis options that you have after you clean up that model, right, depending upon what stream that you took. So it's worth mentioning that there are two kind of internal analysis pathways to where OpenStudio and EcoTect, you can stop there, right? Once you get them in there and you kind of clean up the model, you can perform analysis directly within those programs internally. The other two pathways focus on getting it to Radiance in a flexible format to where we can do all of the high-powered analysis that we can do in Radiance. So, at the lab, we generally have always tried to get it to Radiance, but in practice, you might be able to stop here depending upon the nature of the analysis that you are looking for. So, for instance, OpenStudio is, gaining ground in terms of its ability to conduct daylight analysis. There's a button, within its interface that runs it with Radiance, so you're getting, a format that will export all of this automated, go into Radiance, come back into OpenStudio, and really give you some very powerful information. It does annual simulations. There's visualization capability directly within OpenStudio, and you get annual metrics as well. But not really visualization or perspective renderings and stuff like that, right? So it's good for a certain type of analysis. EcoTect, which students here might have used that in some previous classes. EcoTect has its own internal daylight analysis engine, which is really only meant to be used for conceptual level analysis, right? You generally not use EcoTect down the road for more detailed analysis like LEED. But there's a lot of really great visualization options. There's shading and window optimization studies that you can do directly with EcoTect. There's a lot of great things that it can do. It's just not meant for detailed simulation. So that's what these two pathways are for. That's why there's so many steps. And that's why they're so valuable at the same time. So, SketchUp to Radiance, there's a way to take those files. You have to get them from SketchUp to an OBJ format, to the RAD format, which is the .rad file format that Radiance needs. So there's a whole slew of things that you have to do to prep it for there. We won't get into that too much, but we did want to show those actual pathways. Also, you can see that this OpenStudio has a line connecting to an OpenStudio to RAD as well. So, you have a certain amount of capabilities directly with an OpenStudio on an easy level, but there's a way to kind of prep that and get it into just hardcore Radiance on the back end as well. There's a couple scripts that you can run with the console that the developers have created for us to where you can prep that OpenStudio model into a more flexible format to do some of that high-powered Radiance analysis. So that's always available as well. The last thing I want to mention about this graphic, we're not going to go into those, is that there's these black lines coming back to these programs. So once you come out into Radiance, there are inherent visualization properties within OpenStudio and also within EcoTect. But generally, if you are stuck in Radiance, we have to use third-party software to kind of do these grid visualizations, right? So that's another thing that we have to set up our analysis for, to kind of visualize those results in a way that's meaningful to us, to the client, to make decisions and stuff like that, right? So the kind of how you view data becomes an important implication on these different pathways. So with that, right about at 30 minutes. The last thing is, so we kind of created this workflow legend, and Lauren's going to pick a couple of these ones out to talk about, right? So there's a lot of permutations that you can get in. This is the Revit GBXML import into the free OpenStudio plugin, and you can do a certain amount of analysis there. Or you can, import into OpenStudio, get it to OBJ to RAD, and then Radiance analysis, right? So this is a pretty, there's a lot of information here, but when you break it down into the different pathways, it becomes a little bit more enlightening. So Lauren is going to talk about those, and I'll pause briefly for any quick questions, and then we'll move on. And then remember, we'll have some time at the end for questions as well, but this would be a good time for any general ones. Well, pretty clear. The diagram did the job. Excellent. So with that, I'll pass it to Lauren.
All right, we'll go back here briefly. So thank you, Jake. I guess first of all, I just want to be clear on what exactly we're looking at and what we're trying to get out of the Revit model. Radiance uses various different input file types. There's stuff you can input to define the grid, different sky definitions, time, date, and then there's IES files as well that you can put in there if required. But Revit itself is just going to export and give us the geometry and possibly the material definition. So that's what we are focused in on right now with this. That's what we're trying to define within this little demo. After that, you know, the lab can possibly take it from there. Somebody who's taken one of the daylighting classes can go from there and develop that more in text mode, and it's a little trickier and would require a much longer presentation than the time we have today. So our goals for this really are to get as clean and simple geometry and layers so that we can apply materials to that geometry. So Jake kind of mentioned all of this already. Like, it's really ideal if we have a very simple, even planes, if you're not doing any imagery. If it's just a luminance grid, you really only need planes. You don't need wall thicknesses. You don't need furniture, anything like that. So just getting geometry very simple, no light leaks, no problems with rooms overlapping or anything like that, and try to get as few post-export edits as possible. As Jake mentioned, it's really difficult, and especially Ecotech, to do some of those post-export edits. So trying to get that to come in clean the first time is really what we're going for in these different options. So it's ideal if materials carry through from Revit. We've had problems ourselves trying to get this to work. Some of the thermal properties go through, but reflectances haven't been. There might be a method that maybe we just haven't found yet, or a conversion somewhere that we haven't found yet. But right now, certain properties just aren't coming in for us, so that might be something we have to explore in another presentation, or someone might have some input on that afterwards. But so really the best we can do, as Jake mentioned, is try to get separate layers for different object types so that we can apply materials in groups once they're within SketchUp or Ecotech. So that's kind of the goals for this presentation, to get an idea. And there is no perfect method. Depending on the complexity of your original model and what you intend to do with it, whether you want an analysis grid or if you want luminance or glare image, it might depend on which version you want to use. But first of all, always it's best to clean up and simplify. So Revit models contain so much information, and that's why everybody's going through them. Mechanical, plumbing, landscaping, furniture, any of that that are not necessary. Delete would be best. Save as and delete, all of that would really be best. But you can also just hide them if you want to keep working with that model, like Jake said, depending on how you want to work through that flow in parallel or in one process. And then very important to inspect the model for any gaps or missing elements. Oftentimes we get Revit models and walls are off a little bit, or ceiling planes aren't quite right, and so that causes problems in the export especially, and we'll notice those later on down the road. It's much easier to view them when they're in modeling software like this. It's easy to see instead of find it later on down the road and have to go back and redo all these steps again. So the first pathway I'm going to show is the export as GBXML. I'm going to kind of go through, as Jake did, with these top layers first, and then move on into the transfer programs, as he called them, in SketchUp and Ecotech. And then after that, I'll get into the applying materials, depending on the time. You might have to yell at me if we're getting close. So I'll first do the GBXML and the DXF exports from Revit. Okay, so I've got a pretty simple model here that I've made, and you can see I've hidden a lot of elements, a lot of the landscaping elements, things that are not going to affect the daylight within it. If you're concerned about trees or exterior objects, you can create an object that's not on a landscape layer or an exterior layer, and it will be carried through. Like if you're worried if there's another building or something like that that might affect the daylight, I would encourage you to include that. But a lot of this extra stuff you don't need. So I've turned that off. One thing to note is GBXML will export even hidden items. So I would recommend deleting anything like this little shading structure for a patio. That will be carried through in GBXML, but it will not if it's turned off in GXF or DWG. So those are some things to note maybe for that. So I'll first show the GBXML. And as Jake mentioned, this is a mostly used for energy modeling. So the settings aren't exactly what we want for the daylight model. Surface resolution, which is what we're going to be exporting as, only has a minimum value of 3 inches. So you can see where that might be a problem in larger models where things start overlapping and everything. And there are problems occasionally with that, I've noticed, in more complex models. But for simple models, generally GBXML is a good option because it comes in clean and clear, and it's easy to find things and edit things. So I would recommend that. Another thing that needs to be checked is that the shading surfaces, complex of shading surfaces are selected. We want the roof to be on there as well, and whatever that does to the lighting. So those are a couple of things you have to edit first. As we mentioned, the materials have difficulty coming in right now, at least as far as we can tell. But if there is a capability at some point in time, or if we find it, this is where you would define the material properties that could potentially be transferred through. So there's a thermal tab when editing materials, and we want to make sure that this is filled out, and then the reflectivity as well. Otherwise, it may not transfer through.
Yeah, so the hope would be that you could prep the Revit model in such a way to where when you import it into these other streams, that you don't have to reapply the materials, because as you can see, that's going to be a big part of that model prep. Although we found that that particular reflectivity mark does not show up in the GBXML, right? So that kind of begs the question is, why would we go through this export process when we could just rebuild the model? And as that gets a little bit more streamlined, there's going to be a lot more value for staying within Revit and using that, but we just haven't gotten it to work kind of, bug-free yet. So that's an important part of this, and it just isn't quite ready yet.
So once kind of the pre-prep is all taken care of, you can export to GBXML. So you can kind of see the one nice thing, I think this is a recent addition where you can actually view what you're planning on exporting. And as Jake mentioned, they've included a second export category of rooms as well, so you don't have to set up those spaces like you had to before. And even further than that, analytical services. You can see how that changes the complexity of what you're exporting. And again, if you want to try to export the materials, the thermal properties box needs to be checked as well. Okay. So we'll just do sample project. Okay, so that is pretty much all the GBXML export entails. DWG, again, because you're just exporting the GXF or DWG, excuse me, because you're simply just exporting the geometry, there's not really much setup. The one thing, well, there's a couple of things I would mention. You may want to put glazing on a separate layer from the window frames. Sometimes they come in together, and that makes them more difficult to separate. And it's a lot easier, especially in large models, to change the material of the window panes if they're all on the same layer. So that's one thing I will mention. I won't show that. And the other thing is the unit. Depending on what you're importing into, like if it's Ecotech and you have it set up in meters or inches, just make sure that is correct, or SketchUp is different as well. So. And one last thing, it has to be in 2010 version or earlier for SketchUp to import. Not entirely sure the reasoning, but So now we've kind of gone through the export process. We're not dealing with FBX. We're just going to deal with DWG, GBXML, and DXF because those are the easier methods and the ones that work best with Ecotech and SketchUp. So next we're going to go ahead and take it from the Ecotech and SketchUp level and import these different file types to kind of give you an idea of the process here. So first of all, within Ecotech, within Ecotech, GBXML is actually a supported file. You can just simply open. You don't have to go through an import process. So actually, I know I was going to forget this. Let me take a step back. So when Revit exports the model, it is in a different encoding than what Ecotech will import. So you have to actually edit the encoding prior to importing into Ecotech. So this is simply how you do it. Use Notepad++, which is free. All of this information will be in the step-by-step if you need to refer back to it. Okay. So, okay, so we've got our sample project. Okay, so in the open window, there's all the different materials. And again, for ease of applying materials later, I would recommend zoning these. Zoning is Ecotech's version of layers. So I simply just add new zones. So you'll have like wall zones. You might have interior walls, exterior walls. You'll have roof layers. And I won't go through all of these. I'll do a couple just to show you how it ends up working. And you can click either one of those. So you can see GBXML sets things up in rooms or zones, as Jake mentioned before, but we want them in different material categories so we can jointly apply materials to each of the different object types. So these are the objects that I did not add to different zones. So we have them in their individual different rooms, which we don't want. So I just wanted to show the difference in that. But once you add them to a different zone, then you can turn them on and off together. And it's much easier to select objects on and then apply a material to. So that's the ease of setting the layers up correctly as you go.
Lauren, quick question on this. So where's the surface reflectance in the Ecotech material?
Yeah. Okay. So you can actually edit the materials here. Double click on the materials, or there's another option up there as well, and you can set up the reflectivity here actually. So visible transmittance for windows or the solar absorption. So that is actually where you do it. If you want to apply custom materials, you can create them. And that, again, is in the step-by-step process, I believe, as well. That works? Okay. Okay, and now I kind of like to show the difference. So DXF, again, is full geometry. And you can see how already the layers are set up in floor, glazing, doors, ceiling. So that makes it a lot easier to zone. You just can zone by the item name, which is this right here. And don't forget to set the scale for whatever you export it as. Oh, no. Sorry. imported that into the system. And it does take more time because it has a lot more geometry. You'll see when you visualize this that you actually have the window frames, you have more details. You know, if there's more detail in this model in the first place, it would come in as more complex. And there's wall thicknesses. But the nice thing about this is, again, you can turn off. You can see there's the roof layer and the ceiling layer already, and you can just select objects on and then add materials in that way. And just randomly. So that's how it is a lot easier than GBXML because, again, it wants to zone it by those groups. Now, I'll quickly go into SketchUp. And so I'll do the DXF really quickly. And SketchUp, I actually prefer when doing the DXF or DWG. And the main reason being is it also creates components. So you see when I select this window, I told you there was a problem with creating 2 window panes. You're able to delete all of the second window panes in one simple step instead of having to go through to each individual window and deleting a pane. So these ones are backwards. Apologies, I noticed that. I fixed that later. But so this, again, is all separated by layer. You can turn off all the layers except for a single layer. So we've got the ceiling here, and then create materials and apply them. And I recommend when creating materials, make sure it's unique. It's not just a default, so that you can see them in the Revit, or sorry, the Radiance process once you get to text mode. I was thinking ahead, but that's generally a lot easier. Reverse spaces for DWGs and DXFs, again, you have that wall thickness, ceiling thickness, roof thickness, and everything. And when you're in SketchUp, it has a front and back. And a lot of times it only applies it to either the front or the back. So you'll need to reverse the faces to do that. So again, you would repeat this for each of them. The GBXML is very similar to the import for Revit. However, you have to have OpenStudio. So import in GBXML, and then you can import it from there. One thing we're noticing, though, is geometry is not coming through as cleanly. Sorry, I forgot. So you can see this does not have the shading surfaces, and the floor is missing. Everything else is simplified and would be very easy to use for a daylight model. Again, there's flat planes instead of the thicknesses for the walls, but it's kind of harder to work with than Ecotech. So for the most part, I feel like Ecotech works really well for GBXML. Everything's simplified. Everything seems to come in fairly easily. It's easy to export. For DWG and DXF, it's a lot easier to work with in SketchUp because of that component property, if that makes sense.
So Lauren, how do you apply surface reflectances in SketchUp with the DXF route versus here in the OpenStudio GBXML stream?
Well, okay, so this is something maybe if Alan has any additions to whatever I'm saying, let me know. But we've always just applied material names, and then once we're within console, which is kind of, well, I guess it's within text mode really, I guess we end up editing the materials file in text mode and adding the reflectances there. So we just, again, have material names that are very specific to everything. So we'll have, you know, internal reflectance 50% material or something, and then we'll have BLT 55% material. And then we'll go find those and we'll copy in properties that match those descriptions later on. And I don't know if there's any other options. As far as I know, there's nothing within SketchUp to be able to do that. So.
Studio.
Open Studio? Mm-hmm. Do you know the answer to that?
Yeah, so
I don't know that.
So remember with Open Studio, there's an analysis pathway to where you can go from here, apply materials, and then run it in Open Studio. So if you select, I guess, the inspector.
Oh, yes, I do know that.
Yeah. If you go to any one of the materials that have come through, and we'll actually see what has come through from the Revit properties. Yes, they're all kind of simplified into these no-mass materials. Unfortunately, the name comes through as something generic, so unless I opened up the back end of the GBXML text file, I would have no idea what mat-lay-cons-1-4 meant. In this case, I'm pretty sure it's gypsum, but I mean, you'd have to, it doesn't rename them in an intuitive way. But this visible absorptance is what we would change to do the surface reflectance. So 1 over visible absorptance is the surface reflectance. So, you know, we could make a material that we would apply to all of our walls that would be, I don't know, 0.5, so the opposite would be 50% reflective. We would make one for ceilings, which would be 0.3, so it would be 0.7, so on and so forth. And then we can use the Open Studio hierarchy to apply those materials to the constructions, to the model all at once, which is a whole other kind of demo. But that would be kind of prep. So Lauren's shown the import process, the certain export prep process, and then the analysis process. And remember that you can stop here with an Open Studio outright, but you do have to add some other stuff like analysis grid and stuff like that. But you notice with Ecotect that you could apply materials in Ecotect and run Radiance through it. With the SketchUp DXF route, you have to import the stuff. You rename them in a way that you can see it in Radiance, so you apply materials in Radiance before you run it, right? So these different pathways have kind of different depths that you have to go down to be able to run the analysis. So, you know, just to get a general idea of what those are, strengths and weaknesses was the, I think, point of the presentation and of the demo. Do you have anything else that you wanted to do? If there's one thing that I wanted to point out as well, if you could import another GBXML into the Ecotect. Yes.
All right. Oh, I guess
so, you know, I want to constantly talk about the translation from Revit to these other programs, and this is a way to show, you know, like these are the Revit materials because we clicked on that Include Thermal Properties tab. If we didn't click that thermal properties, checkbox, then they would use the conceptual constructions that are applied to the model in a kind of template hierarchy, but they don't show up in the GBXML export process. So, but even though you get to this point, you can see that it's identifying these materials as a class, roof, wall, window, or whatnot. So it can then apply Ecotect's default materials to the surfaces that have these materials applied to them. So we're not getting these materials into Ecotect. We're just translating the two to Ecotect's default. So that's, I just think in general, is a weakness of the GBXML export process, in that we always have to keep reapplying these materials. But I think that, you know, down the road, we will be able to get those into it, and it's going to make this process a lot easier. So I just wanted to put that out there. So we have about 5 minutes. We're right on schedule, which is incredible. So we can open up to questions either here physically or digitally via the typing pane. And then if you have a question, just go and raise your hand, and I will run the mic to you guys so our online listeners can hear you. So, questions? Sir?
So after you go through all this, you have your final model, whatever you had to take. What's the nature, accuracy, and sophistication of the output?
Do you want it?
Go for it.
Okay. So it depends, just in general. If you stop at the Ecotect internal stream, it's very simplified conceptual level outputs, so, you know, good for early conceptual design, but that's it. If you go through any of these more complex pathways, we've been showing how to get into radiance analysis, and that is the industry, you know, most accurate program because of the way that it does daylight calculations. So I would say that it is probably the most accurate and most flexible output that you can get, although it's really dependent upon the appropriateness of the analysis, right? If you're doing lead daylight analysis, you might not want to go all the way down to Radiant. You might stop at OpenStudio, or you might stop at regular Ecotech. Go ahead. Sure. Yes. So the question is, what exactly are just daylight analysis outputs in general? There are a couple of different categories. One would be illuminance maps, so we could put a grid of analysis points in a room like this and run it during either annual time steps or single point time, and it would give you the amount of foot candles or lux or whatnot falling into the space. So that's what LEED looks for its metrics. The other types of metrics that you would get are visualizations. So scientifically accurate perspective renderings of what the light looks like coming in, and that's where the surface reflectances play a factor there. And then the last type that I would say is glare analysis. So you can get luminance renderings to where you can actually do glare ratios to start to understand visual comfort. Those would be 3 of the outputs. And all of these guys can do that to some extent, but they're all different. Right. It's a good question. Anything else? I just want to remind everyone to go ahead and fill out the physical evaluations on your desk. For our online participants, as soon as you end the webinar, you'll get a ping for an online survey. It takes at most 5 minutes, but the feedback's really critical for us to help hone the webinar experience and also our BSUG content. So let's put it back to questions. Damon, anything online coming through? Okay, maybe run back there.
Here's one for Lauren. In terms of the material export issues that you were having, is it possible to access the text-based files of the project to copy and paste them from old projects, kind of similar to the way that you do it in text mode for IDF files in Energy Plus? Defining material properties or schedules, is it possible to access the text-based files of those and then copy and paste that?
Yeah, it really depends upon the pathway. But so the question is about, can you automate or can you use material properties from previous projects and kind of use those in future projects down the road? And it really depends. Like with Radiance, if you're on the back end, there are material libraries and schedules that you can use and just plug in from a text mode environment. OpenStudio, you can templatize kind of a lot of the material properties, libraries that you do, so you can reuse them. Same thing with Ecotech. So there's even some examples to where you can just organize everything in a spreadsheet and import them into something like OpenStudio. So to a varying degree, yes, depending upon the kind of different workflow pathways that you choose.
Well, and again, like it does export with the GBXML. Some thermal or material properties, it's not the reflectance and it's not imported back in. So I guess theoretically, if you could get those to export, you could copy those properties and then put them in the format of the materials file before going into Radiant. So I guess theoretically that would be possible if that's what they're talking about.
Yeah, it's interesting. Opening up the kind of GBXML file, there's only a certain amount of parameters that get exported from that material layer in Revit. And Lauren showed like 5 different tabs of properties, right? So it's inherently a simplification that just currently doesn't include surface reflectance, which is just the most important thing that we would need for daylight simulation. I think we have time for one more question before I cut everyone loose. There's a lot of online questions, and we'll go ahead and follow up with those via an email too. So in case we didn't get to your questions online, we'll get to them after this.
Exporting from Revit, does the work sets come into play? So if you turn off elements within Revit that are on a work set, do those import anyway?
I don't know if we tried that, Lauren, but
there is information that was talked about. Anything, pretty much, it takes that 3D view, whatever you can see in that 3D view, it exports that. So if you turn on and off different sets, different layers, whatever, it's whatever you're viewing in that 3D view.
Yeah, so there could be a whole protocol of if you're working within someone's Revit model, you don't want to delete things or turn off certain things. You can create your own analysis view that you would use as the export view to get some of these objects out. So, all right, so I just want to remind everyone a couple quick announcements before I cut you guys loose. So there's a lot of information we covered today, a lot of ground. Remember, the idea was to give you a general overview of these pathways in case you wanted to dig deeper into any one of them. This presentation will be uploaded with a video on our resources page. So if you want to check out the website, after this week, we'll have everything up. It will be accompanied by the video recording of this presentation, and then also the Word document that we've created that's the step-by-step process, right? So overview, there's a document accompanying it, it's the more detailed view, and you'll have this video as well. So feel free to check those out, share them with your friends via Facebook or Twitter, whatever you crazy kids are doing these days. And remember that April 4th is going to be the third workflow, right? So if this is just too much of a headache for you, which it is for a lot of people, although it's getting better, remember there's a lot of development around the Daylight add-ins and the embedded analysis capabilities. So that's what our presentation will be on from David Shearer from Autodesk, April 4th, AGC Center, BoyRug/BSUG combination. Definitely worth checking out. So stay tuned for that. Thank you, everybody, for coming.